he is on stage. Please give him an applause. Dr. Claudius Rieck, Zurich Instruments. He has a background, of course, in physics, specialized in quantum optics. And you're managing director of Zurich Instruments in Germany. And you talk about why enabling technologies are crucial for the success of quantum technologies. And with this, I open the stage for you. Claudius, it's all yours.
Great. Thanks a lot. Yeah, I mean, we are on the quantum effects show, so everybody was talking about quantum already, so I think we're missing something here. The slides? I see the slides, but it's a little bit a challenge to describe them one by one. No. Perfect. So, while he's taking care of the technical part, the difficult part can already start. So, yeah, I want to talk why enabling technologies are crucial. And I think we saw that already, for example, Bosch implementing their quantum sensor. There are many elements like a super tiny laser, the integration of the electronics, which is in the end all enabling technologies to make the quantum sensing, quantum computing, also quantum communication possible. And we from Zurich Instruments and also Rohde and Schwarz, we are at the heart of enabling technologies, in this case, especially electronics. And I think this looks already pretty promising. Since 2021, we are part of Rohde and Schwarz, so Zurich Instruments was acquired, and now we are in one of the business units taking care of the test and measurement equipment, not specifically specialized on quantum technologies, but for many applications. Zurich Instruments is, no. Zurich Instruments is actually specialized much more on the quantum side. And now if we get the pointer going, now it works. It's more specialized on the quantum side. But this is the setup. Let's move over to what we are talking when we say quantum technologies. There we are talking about quantum computing, quantum sensing, and quantum communications. And Rohde and Schwarz and Zurich Instruments in the end are involved in all of them. I will focus today on quantum computing mainly because we have a clear mission. We have the mission to engage, to enable, but also to integrate quantum technology. Today, I will focus only on the first two. Let's directly start with enabling the quantum technology. I think now already everybody saw this more or less. You have the setting in a lab, you have the cryogenic, in this case, superconducting qubit in a cryogenic fridge. You have electronics connected to it. You need to send electronics to the qubit to control it and read it out. Yeah? And this is precisely where we come into the game. We are connecting the classical world, depicted here on the left-hand side, the classical world which we can experience, where you can program algorithms, etc., and all the way down to the quantum world, which actually happens in the end in the qubit. And now the question is, yeah, but why would we care about the electronics at all? If we look at the De Vincenzo criteria, for example, do you have the first two? Scalable physical system with qubits, long relevant decoherence times. This is clearly an aspect which is to the physical system. So whatever neutral atoms, superconducting qubits, or other qubit technology. I will not talk about all of them, don't be afraid. But if we look at the other three criteria, you also need to have the ability to initialize the state. You need to be able to measure, to read out the state. And on many setups, this is actually done precisely by electronics. And this is where then the enabling technologies come into the game. And you see now multiple tasks coming from the very left-hand side, where you think about general design of a QPU, for example, in a network analyzer. I think most of you already worked a lot with those instruments. But But there are more challenges on quantum computing. For example, one topic we had is how do you measure actually the phase noise of subsequent control gate sets when you have spurious signals in the on the line in between? And there it's great if you have some colleagues who know how to do that from the radar section, because they solved the problem already. And so this is what we can directly use, and this is where the enabling technologies actually can bring much more than what was developed before for the quantum technologies, but we can really benefit from the know-how and the engineering which we have acquired also in other fields. And what we can do there is we can start at the very bottom, at the very start, where you want to characterize, where you want to bring up individual qubits. There you want to start with, you do the research. There you want to have a great performance to actually see some effect at all first, and then still have the flexibility, because sometimes it's not really clear where you will go in terms of parameters. If we go a little bit beyond that, we have we want to leverage the quantum advantage by implementing functionality like whatever active reset, quantum error correction with super low latencies, for example. This is the field where a lot of research is going on at the moment. But of course, you also want to stay in the same system if you want to go beyond. Yeah? And this is how we said, okay, we think about the direction of 1,000 qubits at the moment, where you want to have maybe a tie-level control system. You don't want to have one control stack, you don't want to have one fridge, but maybe you need to have it really distributed over multiple chips, and you still want to be able to control that. And at the same time, you might want to start hooking that up to a HPC. Maybe you don't. Depends what you're aiming for on the long run. And with that value proposition in the end, yeah, we clearly help startups. We have IQM as an example where we collaborate a lot. Yeah, we help startups by reducing their time to market significantly, mitigating risks. So less capital is required to do the entire vertical integration. This is precisely where the established enabling technologies can help a lot and can in the end speed up the progress. How do we do that? How do we find our partners? By engaging with them. Yeah? I have now here a list of the Zurich Instruments collaborating projects. I would like to highlight the ones which are actually in Germany and Open SuperQ, because this is where I would like to talk about. We are committed in this project to build a 1,000 qubit quantum computer. First 100, if that is done, 1,000. And our task there is precisely take care of the integration of the electronics and ensure that we provide an entire full solution here. And yeah, we do that over quite a long time, so there is a lot of commitment also from the enabling technologies to help push quantum. And of course, we collaborate there with many partners. Now, I would also like to pick a topic which is not very represented here. At least I didn't see it. Quantum radar, a project where we went very early on into a research field where the outcome was not clear. What is quantum radar? The idea is that you use, in the end, you generate entangled photons. Unfortunately, I don't have a pointer here. We start with an entangling set of microwave photons generated at point 1. We propagate it up, it goes to the final target. The idler photon we need to keep in the memory for quite some time to do in the end then the joint measurement, what is in the end quantum correlation at the point 3. We do that together with partners at WMI and with at Rohde and Schwarz. But this is where we really want to kind of show how we can go into very early research to see what we can get out for enabling technologies and what we can learn in addition. And with that, I would like to come to the end also. and summarize our mission. We have the enabling technologies by providing really the whole know-how and portfolio of instrumentation to enable new measurement and new experiments needed to advance quantum technologies. We engage directly with the community, and also we integrate. But about that part, I will talk at another time. And with that, I think, I hope I could convince you how crucial also the enabling technologies actually are for the quantum technologies. And I would like to close and let's push quantum forward together.
Thank you, Claudius. And the question is, do you guys have questions?
No, not at all.
Now let's see. Sometimes they just need a little bit warming up
Good,
and
yeah.
digest everything you said. Tiana is definitely in the back waiting. And maybe you already explained everything so well that there are none, but let's see.
Let's assume there.
Yes. Perfect. Okay, no, then there are no more questions. Thank you so much, Claudius.
Thanks
Give
a
him
lot.
another hands.